Welcome back, scholars, to our final lesson in our polynomial sketching journey. It has been quite the experience, so I hope to this point you've enjoyed the ride. Polynomial sketching is always one of those topics that transcends time. Like I told you before, you'll definitely see this in future math classes. So, mastery of the concepts is what we should focus on. But today we're going to learn to use the remainder theorem to find the remainder of a polynomial so I can comprehend that for a polynomial p of x and a number p of a, the remainder on division by x minus a is p of a. I'll know I've got it when I understand the remainder theorem and why it's true. So, to start, we are going to have a notice and wonder, eat your leftovers. So we have 3 iterations of long division with some numerical statements here. Take a look at what is unfolding mathematically and share with me and your peers 2 things that you notice and 2 things that you wonder. With that being said, we are going to try to determine missing coefficients in polynomials based on knowing a factor of the polynomial. I'm going to go back to the notice and wonder for a second. In 2 out of the 3 instances of long division, you should be able to determine those values that we can describe as factors of the number 330. I'd like for you to think deeply about what that means for a value to be considered a factor. What is the implication, right? The factor is the cause. What is the effect on the original number? Because conceptually, this brings us to algebra, where we should be able to determine the numerical value that is a factor in this case. What is the implication on the overall polynomial if a value is deemed to be a factor? Whatever that implication might be should assist you in determining the value of u. I don't want to give it away here because this is a very powerful question, and I'm interested to see the solution strategies that you're able to generate. So give it your best attempt, and we will have a conversation together. So moving on, we have some diagrams that show the same third degree polynomial, 2x cubed plus 5x squared plus x plus 10 divided by both a linear and a quadratic factor. You should be able to, at this point, know that x plus 3 is a linear factor and x squared minus x is a quadratic factor. If you don't, that's okay, but please make sure you come to small groups so that we can hash that out. Based on what you witness here, what is the remainder for each of these divisions, right? So we can say linear and quadratic. And within each instance, how does the degree of the remainder compare to the degree of the divisor? We should be able to tease apart that there's some type of what's what I'm looking for here. Interesting feature, because next week we'll be talking about rational numbers and how do you wind up having a rational number, a rational function. Well, you need a remainder. You do polynomial division. So can the remainder ever have the same degree as the divisor or a higher degree? Give an example to show that this is possible, or explain why it's not possible. So this will be connecting, that response will connect to your response for the second question on slide 4. Think about it in terms of just numerical long division. Is it possible for the remainder to be a larger value than the number you're dividing by? Maybe, maybe not. In this slide and the following slide, we are using this expression of x minus 2 as a factor. Now there is a very long, tedious road that you can take to determining out of these 6 functions, which would be considered divisible by the expression x minus 2. And there's a very simple shortcut, more like a fence opening rather than taking you know the scenic route, for so to say. So I'm interested once again to see the route that you take. If you have a conceptual understanding of what a factor is and its implication on a polynomial, think about it graphically. This should be very straightforward, and if not, it still should be very straightforward, but in a very tedious manner. And then, here we can explain how we know x minus 2 is not a factor for one of the polynomials. And if you have not already done so, divide the polynomial by x minus 2. What is the subsequent remainder? And that's where we'll pause. Oops, that's the enhancement opportunities. All right, so that's where we'll pause and wrap up our journey through curve sketching.